A very good morning to you guys. Today we are going to look at force. Alright? Now, what is force? I can best define force as a pull or a push. That's how best I can define a force. So by a pull, we are saying we have a block here, and this is a rope, and this is someone with his hands pulling the rope this side. Okay? Then, or might have someone with his hands pushing the block. Okay? So this is a push and this is a pull. Basically, that is a force. Alright? We move to weight. What is weight? Weight is the force of gravity acting on a body. Okay? Is the force of gravity acting on a body. That is weight. Okay? So we are saying we have a body and we have a force that is pushing the object downwards. Okay? So this is our weight. And weight is given by the formula weight equals to mg, where m is equal to the mass of the object and g is the acceleration due to gravity so this acceleration due to gravity g is measured in newtons per kg, newtons per kg, or meters per second squared. You know the units for acceleration. All right. From there, we now want to move to Newton's first law of motion. Newton's first law of motion. Now, Isaac Newton had about 3 laws of motion, and we want to discuss the first law of motion. The first law of Isaac Newton says a body will continue at rest or move in a straight line unless acted upon by a force, or unless a force acts on it, whatever you might want to name it. So we are basically saying a body will continue at rest or continue to move in a straight line unless acted on by a force. So what are we saying here? We are saying an object can iri at rest. It can spend forever iri at rest unless, of course, kana paita object yaita act on it or paita force yaita act on it. Or an object kana ichimuvwa inokwanisa kuramba ichimuvwa forever unless pakaita force yaita act on it. Let me give you a very good example. Tikaseta bhora in motion, dai pasina frictional force ne-air resistance, bhora iri rairamba richienda risingamiri. But the fact that pari kufamba pane friction inoita kuti rizomira, because A inopo air resistance inoita zvekare kuti rizomira. So this is basically what the law says. Okay. Now we need to look at inertia. Now, what is this inertia? Inertia is a tendency of objects to resist change in motion. Okay, basically that's inertia, the tendency of bodies to resist the change in motion. So ukasvika let's say pane drum rine mvura, utanga kushaya kuripusha, unofila resistance kuti harisi kuda kumuvha. That force yaunofila kuti drum harisi kuda kumuvha ndo inonzi inertia, that tendency to resist the change in motion. Okay, now we move on to Newton's second law of motion. Newton's second law of motion. Now, what does Newton's second law of motion say? The Newton's second law of motion is about F equals to ma. So A will be equal to force over m, where A is the acceleration, F is the force, and m is the mass. So the Newton's second law says acceleration is directly proportional to the force directly proportional to the force and inversely proportional to the mass. Okay, this is what it says. So we are saying, or we can simply say, when a body is moving, the force applied is directly proportional to the acceleration. So we are saying if we have a body, maybe it's moving or it's not moving, if we apply a force to that body, the force that we apply is directly proportional to the acceleration. So we apply a force body move with a certain acceleration. So we're saying that force you apply is proportional to the acceleration each move on a body. So what it simply means is you can apply a force yakawanda, acceleration no one. You can apply a force shoma, acceleration no ita shoma. That's basically what we're saying. Alright. Now we need to look at a resistance of falling objects. A resistance of falling objects. Okay. Now, what are we saying when we are saying a resistance of falling object? So we are saying as objects fall down, they face a resistance. Okay? A doesn't want them to fall. So that's a resistance. So what happens? Let's look at an example of a feather falling with a coin. Okay? This is a feather kana kuti munhenga uri kudonha pamwe chete necoin. Alright? So you'd realize that if they are to fall a height maybe 1 meter, the coin is the one inotanga kuricha ground before the feather does. And someone may ask, what is the reason? You'd realize that because of the mass of a feather, the feather is very light, in a mass shoma. So it is easy for a feather to reach what is known as terminal velocity. Now, before I go further, let me define what terminal velocity is. Terminal velocity, we are saying kinetic release an object to tangeta fall. Inodzika ne acceleration due to gravity. Saka acceleration is the rate of change of speed, right? So we're saying as the object falls, speed is changing each way there. So the object will be accelerating, okay, as it falls. Now, if an object can fall a very large distance, inozosvika pekuti acceleration haichachinje. I mean, inosvika pekuti speed haichaincrease. Speed pange ichiincrease ndo pane pachiitika acceleration. But it will come to a point yekuti, let's say something is falling 1 kilometer distance. Chinombotanga chaaccelerata, but chinozosvika pekuti speed is no longer changing. Chakumhanya chasvika paspeed yekupedzisira. So that speed is what we term terminal velocity. Okay, so something chiri heavy chinononoka kuricha terminal velocity compared to something chiri light. So in this case, a feather is light, so inokurumbidza yaricha terminal velocity isati yambosvika a greater distance, whereas coin is much heavier, so inononoka kuricha terminal velocity. So that's the reason why coin ichikurumbidza kusvika pasi before the feather does. Alright. Last but not least, we need to look at Newton third law. Newton third law of motion. All right. Now, what does Newton's third law of motion say? Now, the Newton third law says for every action, for every action, comma, there is an equal but opposite reaction. For every action, there is an equal but opposite reaction. So we're saying, let's say this is a table. If you apply a force, 20 newtons on a table, there is an equal but opposite reaction of minus 20 newtons going up. Okay? So for every action, there is an equal but opposite reaction. So you look at the table at 20 newtons. You know, face resistance is same 20 newtons but in the opposite direction. This is what we are basically saying. So thank you very much for watching. I hope and trust that you have enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at 0784 002 002. And also don't forget to subscribe on my YouTube channel and put a like. Goodbye.